So we will move ahead with our next session for today. So that is also in the category of special invited talk. And our next speaker for today is Dr. Rekha Raja. So Dr. Raja obtained her bachelor's degree from Jalpaiguri Government Engineering College, master's degree in Bengal Engineering and Science University, and PhD from IIT Kanpur. In 2016, she worked as a scientist in Tata Consultancy Services between 2016 and 2018. She did her postdoctoral research at University of California, Davis, USA between 2018 and 19. And currently she is working as a senior researcher at Robotics and Computer Vision Group in Wageningen University and Research at the Netherlands. She has published 10 international journal papers and 16 international conference papers. Her research interest broadly includes robotics, artificial intelligence, robot motion planning, computer vision, and machine learning. So today, Dr. Raja is going to talk about learning manipulation and grasping AgroFood. So welcome, Dr. Rekha Raja.
Thank you, Aniruddha, for kind introduction. Good morning, everyone. It's afternoon. So I'm Rekha Raja, working as Senior Research Assistant at Robotics and Computer Vision Group at Wageningen University and Research. So today I'm going to talk about learning, pushing, and grasping of agro-food products while they are placing in a cluttered environment. So why do we need different kind of actions while manipulating objects or agro-food products? Why only grasping is not sufficient probably for many of the tasks? I would show one video here. Here you can see different objects are put together very closely, and there is no space to go end effector in between those objects. So a robot needs to push to clear the cluttered environment so that it can grasp, it can create space for fingers to move in between to grasp the objects. So this is one really important research field we are working on at the moment, where for example, you have different kind of fruits in a crate, and you want to pick fruits from crate one by one. So you might need this kind of action, this kind of movement while picking objects from the cluttered crate. So before going deeper into the discussion of pushing and grasping action, I would like to introduce agro-food robotics in general, and then what are the main challenges and research vision in this domain. Why we need robotics in agro-food? This is not very popular field in robotics. In agro-food sector, robotics come maybe decades ago. Yeah. So why do we think that robotics can bring a change in agro-food domain? What are the needs? Why human labor are not sufficient at the moment? Because especially in Western countries, they are facing labor shortage in many sectors in agricultural field, starting from agricultural field to the food processing, food packaging industry. So this labor shortage is causing high wages, and that caused the increase in production cost. Even research shows that by 2050, there will be 9 billion population in the world, and we need more food. And the current system we have for food processing is not sufficient to satisfy with the need to feed 9 billion population. So that is why we are looking for automation in food for agro-food sector. And we have observed that there are very highly repetitive tasks in agro-food domain. For example, in food processing industry, human beings stand for a whole day just to pick one object from one place to another. So this is very highly repetitive task which cause human muscle pain and many other physical strength. People lose their mind, and yeah, sometimes it happens that the environment where they work is not very suitable for human beings to stay there for whole days. So there are a lot of things for which we are thinking to automate the agro-food domain, and which might give us advantage in increasing production as well as reduce cost. But the current current technology is not very useful to deploy robotics in the industry setup or agro-food domain sector, because the current robotic system is not flexible enough to handle those agro-food products. Even we need to maintain certain level of hygiene and food quality, and the current technology is also not able to touch that hygiene level we would expect. So robotics can build sustainable agriculture in many different domains. For example, in precision agriculture, robotics can enable ecological farming, and which can improve resources efficiency and then reduce pollution. Then it can contribute to reduce waste. Even it can contribute to improve breeding. Then obviously it can solve the labor shortages as a whole, and at the end it can reduce the cost of the product we are getting in the market, and also it can improve quality. Now there are a lot of challenges in ground level which we need to address before deploying a robot in the agro-food domain. What are those main challenges we are facing? One of the most challenging thing is variation in the product. Here in this image, you can see there are a lot of variation in the products in terms of size, in terms of shape, in terms of color. And of course, there are occlusion. They are placed, put together in a cluttered environment, so you can't see all of the objects. So even there are incomplete information, like as a human being, we can go here and there to look for different things, even they are occluded. But for robot to perform this task in a dynamic agricultural environment is very, very difficult. Also, to handle the agro-food product, we need to ensure the safety. The way human beings handles product, like we have soft hands, which is very, very handy to handle this kind of product. But if we imagine a robot gripper, there is hardly any gripper which is close to our hand. So most grippers we used in the industry currently are very rigid. They are not flexible, soft enough to handle these agro-food products. So to dealing with these challenges, what do we need basically? Maybe we need more robust perception system, the way human being perceive environment, the way human being immediately perceive and then analyze and then take action based on the analysis or based on the perception. So this kind of the brain we have, this kind of system we don't have for robot yet to handle this, to perceive environment. Also, there is like by our eyes we can move our eyes at different directions. But if we imagine we put a camera to the robot, there is hardly any active movement of the camera in any system. We mostly see there is a static camera mounted on the robot. So we need kind of active perception for the robot. And of course, for handling soft object, we need soft actuation system like human hands probably. But there are limitations, as I said, for specific robotic solution. Like there is perception at the moment in the current technology. We always sense something and then plan and then act. So these are sequential things going on. But as a human being, when we do some task, there are multiple things going on together. Like we sense and we plan together. Maybe sometimes we act together. So, but for robot, the current technology always sense and then plan and then act. There are hardly any parallel processing going on. So, yeah. So to deal with the variation, we might need to look for algorithms in the domain of deep learning or in probabilistic representation. We might need also we might need biological knowledge while working in the AgroFood environment. For example, in environment, there are a lot of variation in the illumination, even variation in the task. Also, a variation, as I said, variation in shape, sizes, and everything. So to handle all these things, we need better algorithm. Also, to deal with the incomplete information, we might need multi-view perception or active decision-making systems or continuous update of world model. Like when we perceive environment, we continuously update our memory. Like for instance, now I am seeing something, and next what I am seeing, we are continuously updating our memory. So the same way, we need to create robot memory to update the information of the world. And of course, for dealing with the safety, we need soft robotic mechanism which can handle this kind of flexible objects. We might need adaptive grippers, or we might need tactile feedback, which can have sense of touch as similar to human beings. Now, yeah, these are the challenges and the methods we are looking for. Now, coming to the learning for grasping and pushing, we are working for different to solve different tasks for different applications. So I'll show some of the examples, some of the tasks we are working, and what are the methods we are currently using to solve those tasks. So first one, yeah, these challenges I already talked about, that to automate the grasping, we need to deal with the cluttered environment. Then there is product variation. We need suitable gripper design which can handle this. And yeah. So what are the stages of grasping? Currently in the industry, we see there are a lot of pick and place happening, especially in the assembly line. If we see in the car industry, robot always look for objects which are very predefined shape. Shape is defined. The orientation of their placing is already known to the robot. So we can pre-program to grasp those type of objects. But when objects are variable in shape and sizes, also they are placed in a different random orientation, we can't really pre-program. So what we might need some kind of learning system which can learn, which can see things, which can learn how to handle things. We might need to partially mimic human skill. So that is why where learning comes into picture. So we can go with the traditional industrial way of solving problem in this case. So one of the example I'd like to show where we are working on, for example, in this image, you can see there are pile of tomatoes placed, and these tomatoes are of different sizes. They all are not same sizes, and they are put together. So while picking, you need to segment each of the objects, and you need to determine the pose of objects so that your robot can go to the desired pose and grasp object. So for this task, we have used deep learning algorithm for segmentation, like mask or CNN deep learning algorithm, which will give you mask of each object. And for the pose estimation algorithm, we have used principal component analysis, which will give you three principal axis, principal orientation of the object. So here there is small video. You can see the robot. The gripper is picking each of the identifying objects and estimating the pose, and then coming to pick objects from the clutter. So this gripper, you see, this is designed by one of our student here. This is a very novel design where you see three fingers are going around the surface of the object to pick it. So yeah. So this is how we are performing this tomato pick and place task. I'd show you closely how the gripper works. Here you see there are three fingers going. This gripper is suitable for spherical kind of object. It might not able to pick banana, for example, but it can pick oranges, apples, or tomatoes. Those are spherical shape of objects. So it goes around the surface. And then another work we are doing, that is learning from demonstration. We are trying to, here you can see, we are trying to give a robot to the motion the way human being wants. Here, this person is controlling this controlling robot movement as he wants. So he is giving this robot motion the way he wants, the way human being perceive. Here, this is the this is one tomato. You can consider it as a plant where there is one tomato, and there are leaves which are occluding tomatoes, and robot is trying to reach to the tomato every time. So this person is teaching robot how to move. So he is giving motion to the robot so that robot learns how to move like human beings, how to avoid leaves and then reach to the desired tomato position. So this is yeah, we are doing from learning from demonstration. We are teaching robot how to move. And here you can see we are generating different kind of movement. So that based on the object position, robot learns how to move from its current position to the desired position. So it can go downwards, it can go upwards, it can go sideways. So there can be different movement at different times. When we pick objects, we don't always follow one movement. There can be different movements, and that is what we are trying to teach robot. That based on one particular scenario, it can perform different movements while performing the task. I'll show another example where we are developing algorithms for pushing and grasping of objects to clear the cluttered in the bin. So one of the students developed a reinforcement learning algorithm where there are two networks. One is for pushing and another is for grasping. So when objects are placed together, this network is giving reward for pushing. That robot needs to push first instead of directly going to grasp object. And when it's based on the visual perception, when network is seeing, okay, there are enough space for grasping, then it's giving rewards for grasping the object. So based on different scenario, different visual scenario, network is learning when to push and when to grasp. And here, yeah, here this is one video with the block of objects. It's when there is enough space to grasp, it's directly going to grasp. But when there is no space for grasping, it's going for pushing. But it has been seen that pushing doesn't always help. Like when we are not giving any reward for pushing, the completion rate is 7.8%, but when we are giving reward for pushing, the completion rate is 5.4%. So it is less here. So pushing doesn't always help. So you need to have very effective way of pushing, then only your network will learn very effective way where to push, which direction to push to clear the cluttered. So, but you can see the pushing helps in overall success rate of grasping. Like when it push, it can the success rate is 11.9%. But when there is no push, the success rate is negative. There is no success at all. So while even you see the pushing doesn't always help, so you should have a very effective manner, effective way of pushing your system based on the scene. So we have also apply this algorithm for agro-food products. One video I would show for banana, where here two banana are placed together. Here you can see my robot is going and grasping the banana. So this is very simple case. Yeah, in complicated scenario, it doesn't work very well. Yeah, another task we are working on, where in this video you can see there are people working at the industry who are picking whole chicken from the bin and shackling in the belt. So this work we want to automate. So we want to learn how human beings are performing the task. And the same way we want to teach robot. For example, here, yeah, the robot is able to pick whole chicken, almost similar to the human, but with one hand here. But when humans are performing tasks, they are using two hands. So we have planned to use two hands as well. Yeah, we are teaching robot how to grasp as well as how to push chicken legs into the belt. This kind of task we can't perform in very traditional way. The current robotic setup we see at the industry. So there is something more needed. So we are working towards learning for demonstration or learning by manipulation. And yeah, current research is progressing towards this direction. And thank you. If you have any question, yeah, please ask.
Thank you, Dr. Raja, for the interesting talk. So I would request some questions from audience. Yes, Dr. Aniba.
Yeah. Hello, Rekha. Thank you very much.
Hi.
Nice to see you after a long time, and thank you very much for the talk. It's really interesting. In Essex also we have a agro robotics group, and I'm not actually actively involved, but I'm trying to engage gradually with that group. So I have a couple of questions which I think would be helpful for our project also. So first of all, in a cluttered environment, do you think the standard YOLO algorithm, which is quite popular for object detection, would work, or we need some other type of solution for that?
Yeah, like for example, for this task, we have used Maskar CNN algorithm, which is class of CNN deep learning algorithm, and YOLO is also belongs to that class of algorithm. So YOLO would also work for this kind of task.
Okay, good.
Yeah, good. But what YOLO does, YOLO will give you the bounding box of the object. It will not give the mask of object, like but if we use Maskar CNN, which will provide you the contour of object, so you will get to know the exact shape. But for YOLO, you will get to know the bounding box already. Okay. So that's the difference. But yes, it is of course applicable.
Yeah, and this gripper, is it a soft gripper, or like what's the actually the tentacles which is coming out of the gripper? Is it soft gripper?
This is not soft gripper, but it's compliant.
Like what sort of material is there?
This finger can. This is made with one. You see the belt that is a very thin plastic belt on top of this mechanical.
Okay.
Yeah, like here.
And do you control the pressure, or the pressure is automatically
No,
controlled?
we currently we are using only one stepper motor. and which is like here we have one shaft which by controlling the stepper motor, it's going down and up, and by which these three fingers are coming outside and inside.
Oh, good. So this actually follow the contour of the object, or it has a fixed motion only? So does it follow how the object is shaped?
Yeah, it always go along the surface of the objects.
Okay.
But of course, it has limitation. Like if you give a very small object, which might not fit with this dimension of gripper. As well as if you give very big object, for example, melon, so it won't be able to go go to grasp melon because it's very
and
big.
Also, if the object is deformable, then also it may have some problem, is it? Like if there is the object surface is deformable.
Yeah, we are also reconfiguring this gripper. Like in one side we are trying to put two finger, and on the other side we are trying to put one finger for picking chicken pieces. Chicken piece is very deformable, so we are still not sure whether it will perform good or what. So we are in process of testing.
Thank you. And my last question would be, because there may be others, because I have many questions, but maybe I will catch you later.
Okay.
But my last question here would be, how are you solving the inverse kinematics problem? Is it that like the analytical approach or some machine learning approach here?
Inverse kinematics for
motion planning, for the motion planning, like when there is
okay, at the moment we are using ROS platform for this whole system, and in ROS there is a motion planning package available which called MoveIt.
Okay.
So we are using MoveIt motion planner at the moment, but in ABB, since this robot arm is from ABB, they have also their own software for controlling the movement of the arm.
So the MoveIt can solve the problems when suppose there are objects around, like the obstacles around which it needs to avoid to grasp.
MoveIt can also avoid obstacles.
Oh, that's good to know.
Okay. Yeah.
Thank you, Rekha, very much for your answers.
Thanks for questions. Are there any more questions from anyone?
Yes, I think Nayan has raised his hand. Nayan?
Hello, ma'am. Thank you for your nice presentation. I have a request regarding this creeper. The work is published. Like, if you can share the paper.
Oh no, we are currently in the process of patenting this, so this is not yet published.
Okay.
Yeah.
Thank you, ma'am.
So, is there any more question from audience? Okay. I thank you, ma'am, for that wonderful talk.
Thank you, Anirudh, for inviting